Okay, the other thing, make sure your hair's up above your shoulders, tied up so that it won't drop down into this chuck. This is probably, I don't know, I hate these chucks, but that's what we have. Okay. This is a chuck wrench. The rule for the chuck wrench is it's either in your hand or on the bench. Where does the chuck wrench go?
In your hand or on.
Okay, if it is in the chuck right here, it had better be in your hand. You can take the part out, put the part back in. This is a 3-jaw universal chuck. That means that all 3 jaws move at the same time. Our part should be on center. Out, turn this around. All the lathes that have a handle right here, it goes up. Most of them have to go either out or in. But they're going to turn what direction? What direction do the spindles turn?
They're going to turn towards the bit.
Towards the bit. Clockwise from the motor end is the right answer. All of what you said is true, but clockwise from the motor end is what I want to hear. This is the motor end. Which way should it go?
Clockwise.
Clockwise from the motor end, or counterclockwise if you're where Jacob's at, right? Okay. This is not brass, not aluminum. Can you tell what it is? Okay, if it's steel, magnet would stick to it. If the magnet won't stick to it, it is stainless steel. Well, or something similar to that. Don't touch chips, they're hot and sharp. So another one like that example. Okay, so this is stainless. It's actually 303 stainless. Surface feet for 303 stainless is 110 surface feet. It times that by 4, divided by 1, so, and then I'm going to multiply it by 3 because I have a carbide cutter. And it's 1320 RPM. I have the choice of 1800 RPM or 1230 or 1238 RPM. What would you pick if you were me? And then tell me what the actual surface feet I'll be cutting at would be. 1238. So at 1238 with a 1-inch diameter bar, what's the surface feet? Yeah, just probably between like 105 or something. Close to what we were figuring. So to change this surface feet, or change the spindle speed with this handle up here goes high, medium, and low. So high, clear over here, low where it is now, and medium. No, actually I'm lying to you, that's this handle. High, medium, and low. And this other one selects the spindle speeds. And then you just follow the line around. So I'm going to move it over here. If it gets where it won't move, just turn the spindle a little bit with your hand because the gears haven't meshed. Alright, the most important thing about what we're going to do here today that's new is getting our tool on center. Being on center means being on center up and down. This actually can be moved up or down along this bolt. And right now you can see very obviously that our tool is way low. So center is in the middle of the part and we're way below the center. So start off with, you might want to just look at it, get a good idea of where it's at. If you face the part off, you can see a little spot in the middle. If you haven't, like most of you won't have done, you'll need to go over to the drawer over there on the right hand side, and there should be some of these steel rules. If you put the tip of the tool against the steel rule and against it in between the tool and the bar stock, you just barely touch it, it'll hold it there, and as you raise it up, the tip of the top part of the steel rule will go away from you. If you get too low, it'll go towards you. And if you're right in the middle, it'll be straight up and down. Okay? So that's one not so quick and easy way of getting your tool on center. But that's one way of doing it. We call it using the steel rule. It's tipping towards me, so it's still too low. Okay? So with the spindle off, you go ahead and screw this nut down a little bit lower. This isn't the best way, but it is a way to get fairly close. And hopefully it's better if your steel rule isn't as crooked as maybe this one is. So if I turn it around, let's see if that makes a difference. Still tipping towards me. You can't really tell if you're standing where I'm at, if your steel rule is straight or not. But if you're back where you guys are back there watching, it's a lot easier. I usually will come back here, take a look. That looks a lot closer.
How critical is it being exactly center?
You're gonna, there's a better way than this, and I'll show you here in just a second. You want it to be a little bit below, because if it's high, it's actually gonna rub right here on the tool somewhere. If it's low, it'll still come around and hit the cutting edge. So if you have a question, then it's better to be low. But if you're facing the end of your part off and you're too low, you'll end up with a nub out here. So I'm just going to start this up. Come up here, face it off. That right there is just a touch. You want to touch it as lightly as possible. You're probably on center, okay? And we're pretty close. If you do see a nub, and I'm going to show you what it'd be a nub when we're too low looks like. Then you can just adjust it up a little higher. You can actually see the tool go under that, right? Did you see that from where you're at? The tool go underneath the cut right there in the center. You don't need to go any more. You don't need to go any further than center when you're going across to face it off, because then you're basically running the spindle in reverse on your part, or your cutter, I mean, which will dull it. So that's too low, and you can see a couple of things, because some people will go, I can't tell if it's too low or too high. And if it's too low, it's going to have a really square corner right here, because the tool actually went under and cut a diameter right there by the distance that it's too low. If it's too high, then what it does is it actually hits in here someplace on the insert and just kind of smears the material out in front of it. It'll cut for a little while, and then it'll get hard to turn right here, and we'll end up with a real shiny. Well, that one you can see that it's high, so I'm expecting to lower it before. I've got to admit, that was nothing but just luck right there. So it's pretty close to center again. I'm going to raise this up just a little tiny bit so that it leaves a nice. What it's going to do is it's going to round, it's going to make kind of a rounded little bump in the middle that's really shiny. Okay? So that's how you can tell. Okay, right here it's getting a little bit harder to turn. And right there it's really quite hard. So you have that odd shape. Shaped little bump in the middle right there where we just smeared the material off. We actually burnished it. Burnish it means you just hit it with something that doesn't cut it and just kind of polishes it. Yeah, it just kind of smashes it. Smashes it so it's shiny-ish. Alright, so I'm going to lower this back down. One more way to tell if your tool's on center or not, or get close to being on center. And I usually don't use the steel rule to even start with, especially on manual lathes and the CNC lathes. solid part of the dovetail, and that's right here on the tool holder. And just go up and down and watch the reflection, because as it goes up and down, the reflection is quite a ways away if you're low, and then as it gets closer to center, it gets closer to the tip, and it gets to where the tip and the reflection get to the exact same spot, and that's at the tangent point, which is center line, right?
Reflection in what?
Come here. This is one where you almost have to be right on top of it and doing it yourself to see it. But the tool is actually going to reflect against the part. So if you're close enough, you can see the reflection of it right there. So if you go straight up and down, when it gets to where the reflection and the tip of the tool are almost in the same spot, then you're pretty close to center. And I do that before I do the steel rule thing most of the time. You see it?
Yeah.
So if you want to try it when you get your part, it's a little easier with shinier material than with dull material. But I'm going to say that's fairly close. We'll cut the end of our part off or face our part off with it. And that's really the best way to tell. But a lot of tools you can't face your part off with them. Like the grooving tool, you're not going to face it off. This chamfer tool, you won't face your part off. So the reflection or the steel rule are about the only way to get them centered. See any kind of a nub in the middle or any kind of a bump in the middle, it's on center. Okay.